The surface area of a pyramid is the sum of the areas of the base and all of the triangular sides. So in this case, you can see this has a rectangular base, it's W by L, and then you have two pairs of triangles, this one and the one on sort of the side here, and then the front one, and this one is the other pair, the one on the back, pairs with the front. Now, working out the base of this is relatively easy, it's just a rectangle, so it's WL. However, working out the triangles is a little bit harder, because in this case, we're not given what we call the slant height. The slant height is the distance from here to here along this diagonal line. We're instead given h, which is the vertical height from the middle of the base to the top of the peak of the pyramid. So we need to figure out what this slant height is. Well, to work out this side, we know that this length from here to here is going to be half of the length from here to here. So if the whole length is L, then this length here is L over 2. From there, we have a right angle triangle of base L over 2 and height h. What relationship can we find between these two sides of a right angle triangle and the longest side, known as the hypotenuse? This comes down to something called Pythagoras that you should have covered. So finding this side that we're going to call S for slant height, we're going to end up doing S squared is h squared plus L over 2 squared. So therefore, if we want S on its own, it's going to be the square root of h squared plus L squared over 4. Now, in some cases like this one where we have a rectangular base, you're actually going to have two different slant heights because the length and the width of the base is slightly different. So let's instead call this one S1 and form another right angle triangle where it's still going to be h, but instead of having L over 2, it's going to be W over 2 here because we're sort of working out the length from here to here, which is equivalent from this point to this point here. So this will be S2 for our second slant height. So working this out, we do it in the same way, and that results in S2 is equal to h squared plus W squared over 4. So to actually work out the triangular faces that correspond to this, for this one, as in that's going to work out this front face here, is going to be half times the base, which is W, times by the slant height, which is this, so. And of course, we get a very similar thing for this one. This one would be half L, and then what we had in the square root here, so h squared plus W squared over 4. So putting it all together, remember we have two of these because they come in pairs. The back pairs with the front, and then the two sides pair together. We're going to have WL, that was the area of the base, plus two lots of a half W h squared plus L squared over 4. Make sure the square root covers the whole thing. Plus 2 times a half L times the square root of h squared plus W squared over 4. A little bit tricky here. Again, make sure the square root covers the whole thing. And this will simplify down slightly because you're doing 2 times a half. So you could simplify it to WL plus W times the square root of h squared plus L squared over 4. Again, the square root covers everything there. Plus L times the square root of h squared plus W squared over 4. Making sure that the square root covers everything. It can be a little bit tricky. It is easier if they're a square-based pyramid because obviously W and L would be the same, but you do need to know how to work it out for a rectangular-based one as well. A cone is like a pyramid but with a circular base. We know that the area of a circle is pi r squared, but we then need to figure out what this curved face area is. Now, you don't need to know how to deduce this. However, it would be nice to remember that the curved surface area forms a circle sector when laid out flat, which has an area of pi rl. So, what's the total surface area here? It's just going to be pi rl plus pi r squared, which we can factorise slightly to pi r times l plus r. Again, you don't need to remember that it reduces down to a circle sector, and you don't need to know how this is deduced, just the use of this equation.